Hello everybody, Darko with Poly here. And as you can imagine, with Poly being an integration and automation platform, we want to set the gold standard for what that looks like. So we have some native features that I wanted to showcase today where Poly and Vari will generate events that can be used to process and automate the operation of our platform. So the first one I'd like to show you here is an onUpdate event, which happens on Vari. And in this case, I have it right at the top of the namespace. And then I get to provide a filter criteria to say, hey, if any events happen in these following namespaces, I'd like to go ahead and catch those. You can also target them in environments, at the whole tenant, at particular functions. So you have the ability to express yourself to say, hey, which events should I catch? And in this case, what I'd like to do with this event is I'd like to check if it's a secret. And if it is a secret, I'd like to go ahead and fire off an alert. And in my case, I'm just using Twilio to send an SMS. But with Poly, you have the full programming power here to process these events however you'd like. We just give you the event handler functions so that you have an easy way to catch them and process them. So here I'm just using Twilio, but you can imagine that in a production use case, you might want to log some things. You might want to generate a ticket in a ticketing system. You might want to use systems for alerting to raise alerts and get the right people engaged as soon as possible. But also you might not want to fire off this event every time the variables update, because there might be times that you're undergoing maintenance. So you can even check the state to see if your system's in maintenance, and if it is, just skip the event. So you get a tremendous amount of power, and today I'm just showcasing really the trigger of it and some very simple logic on what I'm doing in my demo to process these. So let's go ahead and fire up the listener here. And this is a Node.js application that's now sitting there, and it has an open connection to the Vari server listening for these events that qualify my condition. So now I can go to my variables here inside Postman, the endpoint that we use to manage our variables. And I'm going to go ahead and just update this value to 234. And I'm going to go ahead and fire off an update to a variable inside Poly. And inside Poly means inside HashiCorp hosted with Poly. So we have an out-of-the-box solution where we can manage your secrets using HashiCorp Vault. And what we do with those is basically just give you an easy way to consume them when building your integrations. And I'll showcase that in just a moment here too. So let's go ahead and hit send. We can see we got a successful update. And now we should have had an event that fired off, and we sure did. The first thing I did was just log the whole event so you guys can see what that looks like. So it's got the ID of the variable that's being updated. It's got the type of event. It tells you if it's a secret. And since it is a secret, it won't actually disclose the values of the previous and the current. But just to keep our event structure consistent, we included those. If it were not a secret, you'd be able to see those values. We got an update time. We have an ID of the person who did the update so that you can audit it, so you can use that as potentially conditional logic to see if this person belongs in a group that has the right to update it, etc. And then we also give you an array of fields that were updated. In this case, it was just a value. But if somebody were to rename it or potentially switch it from a secret to non-secret, etc., you'd be able to see that. Next, we see our console log statement here. And then we should be able to go ahead and go to Google Voice and see a message here showing basically the same thing. So again, pretty simple logic on like what to do with it, just basically showcasing that you have that flexibility to do what you see fit. The next example is going to be very similar, but here what we're doing is we have an event handler function, which basically, let's just go ahead and fire it up so I don't forget. In this case, we're targeting a particular specific value. So just if the token is updated, this one will fire. And basically what we'll get is, again, an event, same structure. Here I'm basically doing some logic to not fire if a particular process updates it, because that's this process. So I'll show you some use cases just in a few lines of code on how you can dynamically update the value using Vari. So we don't want to get caught in a loop is basically what this line of code does. And then what we do first is we actually check to see if the new value of this token is working. And if it is working, we're done. But if it's not working, we want to go ahead and try and fix that. And so what this simple logic here provides is the ability to basically revert back to the other one if the new one doesn't work. So you copy the wrong thing, the new one's not active yet, or something happens where somebody accidentally updates it, then you have the ability to quickly fix that. And the thing to point out here is that the object for the token, it's actually an object. So we've got a model where there's a value with a current and a previous. So you're welcome to have these things be arrays, objects, symbol types, like it doesn't matter. You have the full flexibility to store your secrets the way you'd like to, and to model them the way you'd like to. So we can see here that when we actually do this call to see if it's working, we use Vari, and I've covered this in other videos, to basically inject a value at the time of processing on the Poly server. So these two functions don't actually execute locally. They execute on the Poly server when this function is executed. And so that's why when we inject the token, we have to specify the path to where in the object we find the value that we want injected when it's actually sent off to Shopify to be processed. And then we have a log statement saying that, hey, the request was, here's the status response of this test. And if it is a 401, then we go ahead and try it with the previous value. And then if we get a successful thing, then we go ahead and use Vari function to update it, where we inject the previous value in the object to update it back to the previous value. So you can see a lot of kind of dynamic code where there's nothing hard coded here. It's all basically using Poly and Vari functions to accomplish this. So hence, I used it in my demo to be able to showcase this. And then if it's successful, we just say, hey, we were able to successfully revert it, and we send a SMS message. And if it's not, we go ahead and say, hey, this didn't work. Let's go ahead and generate an alert. And that's basically this function. So again, the moral of the story here is not that this is the logic you should be doing. The moral of the story is that you have the full power to write your own processors for when these events happen. Do you want to log it? Do you want to send it to a security system? Do you want to take some action? Do you want to generate an alert? Do you want to create a ticket for somebody to investigate? Who should be the right person to investigate? So you have all that data here to make those real-time decisions programmatically, so that you can go ahead and make sure the right people are engaged to fix the problem or to assess the problem. Cool. So now that that's running, let's go ahead and fire off another update. In this case, we'll just do 345. And so the current just won't work. The previous will work. I've hid it away as a postman variable, so I don't disclose it to the general public here. And let's go ahead and hit send. So we updated it successfully. Now we see that the event came through again, and then it returned to 401 the first time. The previous one worked, so the previous one was successful, so we're going to try and revert it, and then the actual revert to the previous one was successful as well. So if I try to basically do the same thing, but instead of Shopify token, I'm going to go ahead and set this to just some string. So just foo bar 123. Now we should go ahead and actually go down the path. So it was successfully updated, but this time we'll go down the path of saying that, hey, we got a failure. The previous one failed. So since the previous one didn't work, I'm going to go ahead and generate an alert. And we should see two text messages here. One for the case where it was successfully reverted, and then one for the one where it failed. Now in the next example, I do actually have to use this thing. So I'm going to go ahead and just set this to Shopify token so that it will work for my next example here. Cool. Great. And then, by the way, if you did update it correctly, I forgot to mention that we do have a case here where if it succeeded, we just say 200, great, move on. So that got logged as well. Now for the last one here, I'm going to go and showcase our error handler. And this is a capability we've had pretty much since day one. But I never really showcased it. We never paid too much attention to it to improve it, etc. So we've done some recent improvements where we made the actual error message or error event contain a lot more interesting information so that we can do use cases like what I'm going to do here. So what I'm registering here is that if anything in the namespace Shopify fails, again, you can set it as wide as the entire tenancy. You can set it as narrow as a specific function or set of functions. And so here, this will basically watch for errors that Polly sees, and then it'll pass those down here. And again, you get the full power of writing logic to implement. What do you do now that you see these errors? Do you notify the client application owner? Do you notify the service owner? Do you pass it to a logging system that aggregates them, that then does something different? So you have the, again, full power of code to decide what you want to do here. In my example, I'm just going to log it, and then I'm going to use the function ID from the error to look up the details of the actual Polly function. So that way we know which function is failing. And in my case here, I'm going to then use that information to use OpenAI through a different Polly function to generate me a nice message showcasing what failed. And then I'm going to send that message using Twilio, again through Polly, to basically just alert that there is this particular thing with this AI generated message explaining what the issue is, so that the recipient can quickly understand what to do with it. So let's go ahead and fire up our listener. And what I'm going to do here is I'm actually going to use a different script, so representing a totally different application. And this different application is going to try and access a product that does not exist. So this is a fake product ID, so we should get a 404 if we run it. So we'll fire this guy up. We see that Shopify gives us a 404, which is expected. And then when we look at our listener function, or listener script, we could see that it's got an event that got delivered to us. It includes the message of what happened, some data about it. It's got the 404. It's got the function ID that it failed on, and then the user ID who executed. So in this case, I ran it as a user, so hence there's a user ID that was impacted. If I had run it using an application key, it would have populated this one. So so the event came through. So now we should be able to see that text message with that AI generated message that in this case here came up with API call to Shopify, blah blah blah, failed with the 404, unable to retrieve specific product details. So again, not that this is a great example of what you should do, but more so that you have the full flexibility to leverage different Polly functions and non-Polly functions, and you get to write your own logic to decide what to do with these errors. And this could really help your operations team more quickly get to the right person, get to resolution. It can help you automatically program resiliency, and it can also help your security and monitoring teams be able to quickly detect issues or attacks on your system. So hope you enjoyed this demo. Thank you very much. As always, if you're interested in learning more, feel free to reach out. We're happy to take the call and show you what Polly can do and how it can help your organization. Thank you. Have a great day.